Hey, Natty Grace. How are you? Oh, that's awesome. Way to go. Good job. Cool. Um, well, I'm so excited for you. Wow. And Owen won first and Alec won fourth. Wow, we have celebs in our fifth period math class. That's awesome. Candy for everyone? Question mark? Oh, I'll see if I can get out today to get some, but if not, we'll do it Friday because I'll have a better chance probably on Thursday to do that. All right. Well, I didn't really think about this. I probably should have posted this worksheet on Google Classroom for you all to print out because I handed it out yesterday. Because this was the y'all's work that they had in class, and I taught the concept in class. So I'm thinking I will go back and post this stuff for you all. And because I also handed out the study guide, and I didn't really think about how many I would be missing because I was missing a lot. Would you rather me work a few out or go post it and you print it and then you come back? Which one do you want me to do? I'll put it in yours first. Okay, work a few out. All right, well, we'll do that. And then you just write them down, then you'll have them when you print it out. Is that good? Okay. All right. Oh, I'm just so proud of you. That's so awesome. I'm stoked. So that's so cool. All right, hold on. Just something came in. Oh, wow. Carson won fourth as well. Cool. That is so cool. All my smart babies. That's so awesome. I love to hear that. So we've got 2 firsts, 2 fourths. That's great. Okay. Let me pull this up, and I'm going to kind of go through a little bit of what we worked out yesterday before I go to the worksheet. This is the other thing that I handed out in class. And just confirming, can you hear me okay? Okay, good. Overall, we had like 5 or 6 firsts. Oh, wow. That's awesome. Cornerstone really did good. Oh, that's so exciting. Very good. Okay. And like I say, I will post this on Google Classroom or for you to print out, or, I'll obviously have it when you get in class tomorrow. But kind of what we talked about yesterday. We did go over some vocabulary to start the class. Just right here where it says a monomial is a number, a variable, or a product of a number and one or more variables. I just basically wrote on the board and said, you know, the number 9 is technically a monomial. 9x is a monomial. 3x squared is a monomial. So basically just one thing or a product of two things, because when you write a number and a variable right next to each other, like this one, that's technically understood multiplication when things are going on like that. So that's really 9 times x, except we've eliminated the multiplication symbol. And this number right here is 3 times x squared. But this whole thing right here is a monomial. The 3 right here is called the leading coefficient. And that is the actual digit that leads a monomial. And then the degree of a polynomial is the greatest degree within the term. So this is a second degree polynomial. This one right here, there's an understood 1 there, so it's a first degree monomial. So, and then a polynomial, a monomial? You haven't heard of it? Oh. No. A polynomial with 2 terms is a binomial, and that's what we're going to be working with a good bit. A polynomial with 3 terms is a trinomial. And when you multiply, which is what you're going to be learning today, when you multiply 2 binomials, you will get a trinomial. So just kind of to combine yesterday's lesson with today, that's some things. But like I say, you will be getting this study guide, so no, don't panic. But I just feel like I need to kind of go over this with you before I start on the actual classwork, because it might be a little overwhelming if I don't. Now, down here, rewriting a polynomial, you write, when you're writing them, you want the exponents to decrease from left to right. So you identify the degree in the polynomial and the leading coefficient of the polynomial. Okay, so that's what you do first. So if you look at this one, this is 12x to the third. The degree is 3, and the coefficient is 12. When you look at this one, the degree is 1. The leading coefficient is negative 15. And when you look at this one, the degree is 5. The leading coefficient is 13. And what I stressed in class yesterday is when you're rearranging these polynomials so that the exponents, the degrees of them, decrease from left to right, you have to make sure that you carry the sign with the leading coefficient. And I stressed to them by saying every sign has a number and every number has a sign. So when you're moving them, this would move to the front because it has the greatest degree. So you have 13x to the 5th. Then the next one is 12x to the 3rd. And the understood sign, when there isn't one in front like there is on the 12x cubed, is a positive sign. And then when we put that final one, which is the negative 15x, remember we had to carry that sign with it. So kind of when you're getting with polynomials, that sign is also the operation. But so it's kind of fitting 2 different things there, 2 different things there in one place. But because technically, when you're rewriting that, just when we first started learning about integers, we would have changed this to a plus a negative 15x. I'm going to check back with you to see if you have any questions so far. Okay. Just to make sure all of that part so far seemed clear. Is that good? All right. So then the examples down there, those are the ones we did in class. We just kind of rewrote them in degreed order from left to right. So your exponents were actually decreasing. So we did a little bit of that in class. And then moving on, because I want to at least get to some of the classwork for you. Do you want to try some of those, rewriting them, or do you feel pretty good about that? I also did warn them that on the SAT and the ACT, and perhaps even in the Math Olympics yesterday, that's one of the ways they'll kind of throw you a curveball by not putting those in order. And the first thing you always want to check is the polynomial in decreasing order. That's definitely something you want to check. You do want to work some of these out? Oh, okay. And then I'm just going to move on. Okay. Then I showed two different ways to add polynomials in class, a vertical and a horizontal. So what you would want to do is, you can see on this form here, this particular one, they rewrote it in a vertical format, and they put the polynomial in decreasing order. It already came that way. But if you'll notice on this particular one, it didn't come in order. So while they were writing it in that vertical format, they put it in order. Yesterday in class, I also suggested, and this is up to you. You see on this one was missing a term on the end. So you can put a placeholder by adding 0 there if you want to, if that helps make sense to you. And you could also put one here, because if I add 0 to anything, I have not changed the value in any way. I've just made sure that I have terms at the top and the bottom. So then once you get it all in order, and you can see vertically that each one of your terms lines up with matching degreed exponents, because you're going to be combining like terms. That's what you're doing here, is you're aligning like terms. So you've got 0 plus a minus 2x, which gives you negative 2x. 5x squared plus 7x squared is 12x squared. Then negative 2x cubed plus a positive 9x cubed gives you a 7x cubed, and 3x to the fourth plus 0 is 3x to the fourth. So this is your final answer. Now on the second one, you confirm first that your terms are in order, and they actually are. 7x cubed minus 3x plus 6, and then 9x squared plus 6x minus 11. You can see that they're in order. So what they do in the horizontal format is they actually group like terms in parentheses. So they put 7x squared plus 9x squared in parentheses. Then they put a negative 3x plus 6x in parentheses, because those are like terms. So you're grouping like terms and then simplifying. And then finally, they have a 6 and a negative 11. And then they actually go back and simplify. 7x squared plus 9x squared is 16x squared. Negative 3x plus 6x is a positive 3x. And then 6 minus 11 is a negative 5. So then that's your final answer. So that's the way you do it. You can choose vertical or horizontal. It doesn't make any difference to me which one, and you're not going to have to show me both. Those are the two ways that you can do it. Yesterday, it seemed like in class, we had a few people that really liked the vertical. It seemed that to be the default, you know, whereas more people seem to like the vertical. That's right. Different exponents are completely different terms. So 16x, like if you're looking at that last final answer, the 16x squared plus 3x minus 5, that is your final answer, because no more of the monomials within that have matching, you know, exponents. So they cannot be combined. I think, you know, this is dusting off some cobwebs, but way back when we were doing one of the color worksheets, and I believe that oh Lord Jesus, the one with the heart, the one that I had y'all do for quote unquote Valentine's Day. One of those actually where we had to combine like terms, and we hadn't really gone over that with the exponent rules, but one of them we had to do that with, and that kind of corresponds to this lesson, whereas a like term is something where it shares the exact same variables with exponents. So obviously your constants or your leading coefficients aren't going to be the same, because that's what you're going to be combining, but the variable has to have like exponents. So good job of noticing that. All right, I'm going to move on to subtracting unless you have any more questions. You like the vertical also? Yeah, it seemed like out of all 60 of my Algebra 1 students, I had maybe 5 that liked the horizontal. But, you know, vertical just seems to make a lot of sense because everything's lining up. So, so we'll, let's see. I'm going to go on to the subtraction now. All right, so now we're going to be finding the difference. And the key thing here, and I kind of reminded everybody, remember when we first started doing the distributive property, probably back in 6th, 7th, and 8th grade, is that when, especially when you started working with integers, is to make sure you're distributing a negative all the way through. And so it's kind of like almost multiplying that whole second polynomial by a -1. But you'll see that as we work through this. So once again, you always want to make sure that the polynomial itself is lined up in order, making sure that you're starting from the largest degree and working, you know, in decreasing order. Well, in this case, in both A and B, they are in descending order. So the vertical format would look like this. You're going to align your like terms in the vertical column. So we've got 3x squared minus 9x. Then on that next line, what you're going to want to do is write your subtraction sign, which they've done here, and then go ahead and put your whole second term in parentheses, okay? Because you're going to want to think through and distribute that negative, and then you'll treat it like an addition problem. So it's almost like keep, flip, change. So when you distribute that negative all the way through, you take that negative, and so negative, that will change that positive 2x squared to a negative 2x squared. It will change the negative 5x to a positive, because you'll have a minus 5x, and then it will change that last positive 6 to a negative. So now this actually has become an addition problem, because you've kept the first and you flip this to an addition, and then you've distributed this negative all the way through to keep, flip, change to every single term in that second polynomial. So now you've got 3x squared minus 2x squared, okay, which gives you x squared. And then you've got a minus 9x minus a positive 5x, which gives you a negative 4x. And then you've got, once again, if you want to, you can do the placeholder that I was talking about before right there. And you've got 0 minus a negative 6, or a 0, I'm sorry, 0 plus a negative 6, which would give you a negative 6. So, and then that would be your final answer. Okay. So how does that all make sense to you with the, like the keep, flip, change, and still aligning it with vertical? Excuse me, Natty Grace. Sorry about that. I had a whiny dog that needed to go out. I apologize. Okay, do you want to see the horizontal method for the subtraction, or do you want to just stick with vertical? Want to go over both? Okay, all right. So do you want to just start on some of the worksheet then together, and then I can email it to you? Okay. All right, let me switch the screen. Okay, so this was the handout. And there's 20 of them. There's 10 on the front and 10 on the back. And the reason why I did that, there's some more exercises also on the handout that the other handout that you and I were working through together. But the best thing about this is just really practice makes perfect. And you being in Math Olympics, I'm sure you know that better than anybody. But just making sure that you're practicing this is the best thing that you can do for yourself, really, to get better at these things. So in this first one, I can already tell that they're not lined up. So the very first thing I'm going to want to do is line up this first one. Okay. So I've got a negative 5n to the fourth. Okay. And I remember every sign has a number and every number has a sign. So that's why I carried that negative up front. A lot of times students will look at this and think it's a subtraction problem and that you can write it any way, but that's not true. That negative has to stay with that 5. And so the understood sign in front of the 7n squared is a positive. So I would write it like that. And so then on this second one, I've got a negative, and I have to distribute that negative throughout the whole second polynomial. So that's going to make that a minus 2n to the fourth. So I'm actually technically keeping, flipping, and changing, and then that will actually turn into an addition problem. But a minus n squared is going to make that second one a positive n squared. So what I've essentially done is distributed the negative all the way through. And now I've got an actual addition problem. And I've lined up my matching like terms. So I've got 7n squared plus, and the understood coefficient on n squared is 1. So that's going to be plus 8n squared. And then over here, I've got a negative 5n to the fourth and a negative 2n to the fourth. And when I combine those, that gives me a negative 7n to the fourth. So my final answer is negative 7n to the fourth plus 8n squared. Okay. All right, I'm going to click back over and see if you have any questions. Oh, good. You got it right. All right. Good job. I think what I'm going to do is skip down to number 8 because we've got a trinomial there and it's addition. Or actually, let me do one more subtraction with a trinomial. Let's do number 5, and then I'm going to do number 8 so that we're working with some trinomial binomial ones so that we have to kind of rearrange things and we're all actually having to do some placeholders. So let's start with 5, and then I'll go on to 8. Let me erase all of that. Okay. Okay. I'm going to notice in that first polynomial, number 1, they're not in order. Number 2, if I look in that first polynomial, I've got a negative, I've got an n to the fourth, which I have in my second one. But in my second one, I've got an n cubed, which I don't have in my first. So I'm going to want to do a placeholder there. Both the first term, or both the first polynomial and the second polynomial have an n squared. So I'll make sure that my n to the fourth in both polynomials line up vertically. I'll have a placeholder for my n cubed, and then I'll have, then I'll line up my n squareds. So I'll start like this, remembering that every sign has a number and every number has a sign. So when I rewrite this first polynomial, I've got negative 2n to the fourth. And then I don't have an n cubed in this first one. So I'm going to go ahead and set a placeholder of 0, remembering that I can add 0 to anything and it will not change the value. So I'm okay doing that. And then I'm going to put my 2n squared, remembering that if there's no sign out front, the understood sign is positive. And now I have to distribute this minus throughout the whole thing. So I'm kind of keeping the first and then changing that or flipping this to an addition sign and then distributing my negative. So that negative goes to that 5n to the fourth. So that's going to make it a negative 5n to the fourth. And then I'm going to skip all the way over to the end there because my 8n cubed needs, my negative 8n cubed needs to go next. But if I distribute a minus to a minus, that makes it a plus 8n cubed. And then my final term, when I'm taking them in descending order, is going to be this 6n squared. When I distribute this minus sign to the 6n squared, it's going to be a negative 6n squared. And now I'm actually ready to do the operation. So I've got 2n squared plus a negative 6n squared. That's going to give me a negative 4n squared. Then I've got a 0 plus 8n cubed. So that's going to give me a positive 8n cubed. And then I've got a negative 2n to the fourth plus a negative 5n to the fourth, which is going to give me a negative 7n to the fourth. And that's my final answer right there. Okay, how'd you do on that one? Or did you just follow along with me and write it down? Oh, good job. All right, you want to do one more? Let's do that number 8 together, like I said, one more for practice. And then let me know, do you want me, okay, and do you want me to go through some of today's stuff as well, or do you want to kind of let this set in and then maybe you'll do that later? I don't blame you. This particular lesson, I think you'll do very, very well on it, but you do have to take it bit by bit. That's for sure. All right. Let me switch back over and I'm going to erase this. Puppy, why are you so whiny? Go lay down, buddy. You've already been out, sweet pea. All right. Number 8. Okay, so our first term has a n cubed and an n. And our second term has an n cubed and an n, but it also has a constant. So as I'm lining these up, I kind of want to remember that I'm going to put a placeholder in for that constant. So 4n cubed, there isn't any n squared in either one of them, so I don't necessarily need a placeholder there. So I'm going to go ahead and write down my 6n, but I'm going to put a placeholder in for that final term for that constant. And typically when you're writing these in order, if there's a number all by itself, it is called the constant, and it will be at the end. All right. So then my second one, I don't have a plus in the, I don't have a negative in the middle, so I don't have to really distribute anything. All the signs are going to remain the same as I write them down. So I just want to make sure that vertically I line up my matching terms. So the matching term in this second polynomial is 3n cubed. And then I've got a negative, because remember, I've got to carry that negative with it, because every sign has a number and every number has a sign. So I've got a negative 7n plus 1. Okay, I'm in math lab. And so now I'm going to add my like terms. 0 plus 1 is plus 1. And then 6n plus a negative 7n is going to be a negative n. And you could write negative 1n if you wanted to there, but the understood leading coefficient on a variable with no leading coefficient is 1. So you could just, either way that you write it, it wouldn't be wrong either way. But and then you've got 4n cubed plus 3n cubed, which is 7n cubed. And that's your final answer for that one. Definitely a little less to remember when it comes to, oh yeah, there it is. Good job. And I like how you wrote the plus negative n. That's really good. That's good. Okay, good job. So a little less, a little less to remember when it's not subtraction. That's why I wanted to do a couple of the subtraction ones on this worksheet, But the key thing to remember, a lot of students yesterday in class weren't wanting to try and rewrite everything. They were just trying to figure out how they could maneuver it using the numbers that are on there. But my recommendation is just to rewrite everything and kind of make sure everything's lining up, whether you're doing it horizontally or vertically, just to make sure you're lining things up and just getting good. I figured that that's what you would do, but that's my definite recommendation for doing that stuff. But I will definitely post these worksheets on Google Classroom, for you. And then tomorrow in class, I kind of gave everybody a heads up about what we were doing, but it's an activity where there'll be task cards around the room, and you'll be figuring out or calculating the perimeter and the area of rectangles where each side is actually a binomial. So the perimeter, obviously, you're going to be adding all of the sides together. And that gives you the perimeter. So you'll be adding binomials, and then you'll be multiplying binomials to get the area, because length times width is the area of a rectangle. So that's how you're going to be processing some of this information. So you'll get to do some more addition tomorrow as well. So that'll be helpful to be able to practice a little bit more. Unless you would like me to do some more now, and I can. Would you like me to work through a few more? Okay. All right. Well, I'll let me go ahead and post. Okay, no problem. And congratulations again. I'm so proud of you, Natty Grace. I know you work really hard at all that stuff, and that's so amazing. Thanks for representing our school so well. And I feel so stoked that you're in my class. I have a celebrity in my class. I know. How about that? I mean, that's amazing. Absolutely amazing. So cool. Oh, wow. That's pretty cool. Well, he definitely likes the math. That's amazing. And I know that you do too. You're working really hard. So those competitions, yeah, I know. I like math too. I'm not as fast. I'm not a real fast. I am obviously at some of this. I'm a little faster now because I've been doing it for so long. But like when I was first learning math, I absolutely loved it because it made so much like logical sense to me. Everything seemed to kind of have a place and there was an order to it, which is how my brain seems to think more. But I wasn't as fast as you guys were. Like, on level, I would never have been able to beat you in a race or anything when I was in school. I mean, I would get a lot of answers right. I just wouldn't have considered myself to be the fastest. And I think a lot of times I definitely was never a step skipper. So that always takes a little bit more time. Whereas a lot of times I think some people can think through some of the steps quicker than I can.
In sixth grade, we played a game called Squat, and I would always win, except for when we were doing it on paper and not on the board for some reason.
Oh, really?
Mm-hmm.
Oh, okay. So you work it better on the board. And I'm actually the exact opposite. I feel like sometimes when I'm at the board, I just feel like, oh my gosh, it like just vanishes from me. It's crazy, but I can work it pretty fast. But it was real interesting. You know, I've tutored math for many, many years. And I had one student that I actually tutored that I think his was just, it was just a confidence thing because he could always beat me in a race. Once I had gotten everything explained to him of how he needed to do it and I had worked out the steps, he could always work through them so much faster than I. But it's that's kind of fun. But you know, but like I say, you guys are really sharp, just so smart. And I'm just so proud of y'all. And I know you worked really hard. So,
Thank
and
you.
I know you have to work hard to catch up too. So, you know, I'm praying, you know, for you guys, but I know you'll do well at this. And once again, thanks for representing our school so well. I'm so excited. That's amazing. But you have a blessed day, and I'll get this stuff posted for you, okay? I'll actually post your class first.
Thank you.
Okay, sweetheart. You take care.
Hey, Mrs. Clark.
Hey,
I
how are you?
good. I just
Hold
wanted.
on just 1 second. I'm posting the class, like the class handouts from yesterday on the Google Classroom. And congratulations to you.
Thank you.
I appreciate it.
I was just wondering if there was like any big things, like big, huge concepts I missed yesterday in class.
Yeah, I actually went through all of them on Math Lab just a few minutes ago. Hold on just one second. I'm trying to get back to the actual handout itself so that when it pops up, you'll see. And then I'll share it. Yay. Here it is. See it?
Yes, ma'am.
We actually went through all of the study guide yesterday, and the examples, and then I had a handout that I did. Instead of doing textbook problems, I actually did stuff from the handout because for the class. But we're going into polynomials now, and the first section is adding and subtracting polynomials. And the first thing you want to make sure you do is rewrite a polynomial in order from decreasing degrees to like all the way from left to right. So your highest degree monomial to your lowest degree. And that's the very first thing that you'll want to do. And then you'll, the actual study guide itself, I'll kind of flip through that, shows you how to either line them up vertically, or you can group like terms together and add and subtract them horizontally. Kind of your choice. But the study guide actually goes through those with you. And like I said, I went through it. So in the math lab, and if you want to, I think you can actually pull the math lab up.
I can. I have the archive.
Yeah.
So I'll probably go watch that.
So, and then that will help you. And then I actually did like what you might want to do before you do it is print these out from the Google Classroom, because I actually did 3 of the classwork homework problems.
Okay.
So, and then tomorrow in class, what I'm doing is there's going to be task cards around the room. Okay. So we'll be having an opportunity to add polynomials and multiply, because what you'll be doing is finding the perimeter and area of these particular rectangles. And obviously the perimeter is going to be adding all of the sides, and each side happens to be, the measurement happens to be a binomial. And then you'll also be multiplying to find the area, because length times width is the area of a rectangle. So you'll be multiplying the binomials.
Yes, ma'am.
So you'll get an opportunity to be able to work at both of them with me, and then you actually, then there's 10 task cards, and each task card has area, perimeter. Actually, for your class, there'll be 12 because there's 2 challenge problems.
Yes, ma'am.
One is a circle and one is an odd shape. So, but I only have those for 4th and 5th period.
Okay.
But so you will be able to do some of this with me. Is Brittany with you today?
No.
Oh, so you're kind of solo in it. Bless your heart.
Oh, no, it ain't.
Okay.
Multiplying polynomials yesterday. Alexa, I was not talking.
Say that again.
I was talking to my Alexa. She lit up.
Oh, Well, I have a greyhound that's really whiny, and that's she's whining in the background, so I'm really sorry about that.
It's not her. It's probably It's probably me.
No, she's been whining ever since I got on math lab 30 minutes ago. I've let her out. She has water. She has food. She's just staring at me eye to eye as I sit here and talk, whining.
Dogs do that, man. My dog's like that.
I'm just like, what are you doing? You have everything you need. Please go lay down.
You can give this dog anything she wants, and she's like, I desire more.
I'm like, oh. So anyway, I'm so excited for all of my students. I'm so proud of y'all.
Yeah.
Cornerstone represented well.
Oh, yeah, we killed it yesterday.
Yes. I'm so proud. That's just absolutely amazing.
It was really good. Because I mean, we were a majority of the we really destroyed.
Yes, y'all did. And I'm like, yes, way to go.
Yeah.
All our little math geniuses.
Natty Grace got first in her category. I got third. Owen got first in my category.
Yeah, I was like, man, everybody did so good.
Yeah, everybody really did amazing.
Yeah, really amazing. I'm just so stoked.
Me too, man. It was a blast. One thing I don't like about Math Olympics is they won't give you back your questions, so you can't figure out what you missed.
Oh, that's kind of sad. That would bother me.
It does. It bothers me because I'm like, well, I know this whole thing's about learning math, but I can't learn math because you won't give it back to me.
Yeah, I know. You know, it's weird. The SAT, ACT, you have to pay extra for them to give you your stuff back. So anyway, I mean, I did that, for Mackenzie, just in case she needs to take it again, so we can see, where we have to, do, like where if she needs to, what areas she needs to specifically study. But I'm like, wow, I just wish they would just give it back to you.
Yeah, it's just kind of annoying because it's like, well, it's the least, I mean, it's just dumb, kind of.
Amen. Amen.
Like, it's not like I worked on this for a bunch and this point is to learn. But,
yeah,
it makes me mad.
I hear you. I know. I wish they would too. So that way, because last year, next year will be your last year of getting to go, because I don't think they have it for high school, right?
They don't? Well, I guess.
I don't know. I don't think they have us prep anything for high school students. I'll have to double check, but I don't think so, because I know we kind of have to, like 7th and 8th grade teachers have to kind of prep things.
That's weird, man.
So, yeah.
Well, I kind of expect that, because if you really want to get into math competitions at that age, there's like tons of stuff like that.
Is there?
Oh yeah, there's like they have a ton of stuff at that age. There's tons of stuff that I've been researching.
Oh, okay. Well, I guess I wasn't aware of that.
Yeah, because there's like undergraduate, like high school or college, PhD competitions, tons of college and high school level math competitions.
Oh, well, I guess I wasn't aware of that.
I wasn't recently.
I went to a math competition when I was in, I think, 7th grade. I can't, but that was the last one that I went to.
Learn something, because I really never thought about it.
Yeah. But like I say, I know part of this is speed. And I was just telling Natty Grace earlier, speed has not always been my forte in math.
Like
I'm methodical, but I lack speed. You know, I can solve almost anything, but I'm not going to be the first one in the room done.
yeah.
So, but I mean, you know, that's okay. Everybody approaches things differently. So, you know, and I was telling her, I said, obviously, I've been tutoring and teaching this particular concept for a long time, so I'm a little faster at it. But you know, that's a whole practice makes perfect kind of thing.
Yeah, definitely. Because, you know, you can't just be amazing at something on your first try.
Yeah. And so, you know, some of the other concepts and things like that are a little harder that I don't do as much. I'm still that slow, methodical worker. So, but I enjoy it. So it's like I love learning new things about math all the time.
Yeah.
But anyway, well, I was gonna say, like I say, I posted all of the worksheets, but I'm getting ready to do Algebra 2 Math Lab here in just a second. So I've got to pull up all of my documents and do that. But I look forward to seeing everybody in class tomorrow. I told Natty Grace that we would celebrate. I may not be able to get to the store today to do celebration, but if not, we'll celebrate everybody's, awesome wins on Friday in class.
Okay, that's going to be fun.
Okay. All right. Thanks again for representing Cornerstone so well and working so hard. I appreciate it.
No problem. Bye.
Bye-bye. Have a blessed day. Bye-bye.